Welcome back to the class, guys, and I hope you guys are doing pretty good. In today's class, I want to discuss a very important interview question, which is reverse a link list. Now, if you're appearing for any product-based company, I'm not talking about any MNC company like Accenture or Infosys. I'm majorly talking about product-based companies. You will definitely get this particular question, reversing a link list. Now, over the internet, whether you go to Telegram or whether you go to YouTube or even on LinkedIn, they would definitely have tried to explain the linked list concept or, like have given the code on how to reverse a linked list. But I want to take it in a much more different way. Okay. We will definitely come to this particular question of linked list on how to do a reversal of a linked list. The first goal that we should be focusing on is understanding linked list. Okay. So first, what we will be doing is we will understand how linked list works. All right. We will compare linked list with array because linked list is also a data structure. All right. Once we understand the difference between an array and a linked list, we will go to Eclipse and we will try to create a linked list. Is this part clear to everyone? Okay. Once we are confident on the working of a linked list, how the data is stored, how the traversal happens, then I'm pretty sure you will be able to understand the reversal of a linked list. Is this part clear to everyone? So even though I want to discuss this particular problem, I'm going to take a longer route so that we can have a very strong foundation on our data structures. Okay. I don't just want to discuss this particular solution, okay, and wrap it up, because in longer run, maybe you will forget this particular logic. So it's always better we build our foundation step by step. We get the confidence on working on the linked list, and then we'll come back to this particular problem. Is this part clear to everyone? Great. Now, this particular lecture, guys, is going to be divided into two parts. The first part, we will be just discussing on the concept of linked list. All right. So, the first thing that I want to discuss in today's class is what is linked list. All right. And we will then write some code. Okay. So, this will be the first part. And the second part, we will be talking about the reversal of the linked list. Is this part clear to everyone? Perfect. Great. Now, if you have your mobile phone, all right, I want you guys to put it in the flight mode. If you can't put it in the flight mode, just put it in the next room. Okay, keep it in the next room. I want zero distraction for this particular lecture. All right. I am pretty sure most of you guys are doing it for the very first time. So our first goal is to understand this particular topic properly. Generally, I tell people to watch the video at 1.75x and all those things, or 1.25x. For this particular stuff, take it as slowly as you can. All right. So I want your notebook and pen along with you guys because we have to make a lot of notes. All right. Let's get started with the concept of linked list. Now, what do you know about linked list? Anyone? What do you know about linked list? You can say that linked list is what? It's a data structure, right? It's a data structure. Now, if I ask you what is a data structure, we have seen it a lot of time, right? If I ask you what is a data structure, what are you going to say? You're going to say that data structure basically talks about how the data will be stored in the memory, right? Yes or no? We're going to go very basic now. Okay. What is a data structure? Data structure basically talks about how the data will be stored in the memory. Do you agree to this particular point? Perfect. In the logic building module, we have seen a lot of data structures. Technically, we have seen only two data structures. What are the two data structures that we have seen so far? We have seen array. And the second one? Yes, you have seen your stack data structure. Array and stack, they both are linear data structure. Okay, linear data structure. So over here, your linked list also, guys, is a linear data structure. So linked list is also a data structure And what kind of a data structure it is? It is like your linear data structure. Now the question that comes into picture, Jatin, array is also linear data structure. Stack is also linear data structure. Linked list is also linear data structure. Then how they are different from each other? And that's where your next interview question basically comes into picture, where a lot of people ask about what is the difference between an array and a linked list. All right. So we'll try to understand the theoretical part of array versus linked list, and then we will discuss more about linked list. Now, guys, if I ask you, how do you create an array? Yes, how do you create an array? Tell me the syntax of creating an array. Integer a square bracket is equal to new int of 5. So, is this my array? No, this is what? Reference variable. Okay. What does reference variable store inside it? Reference variable basically stores the hash code of the array which is going to be created in dash memory. In which memory do you create the array? In the heap memory. Now tell me something. How do I know that the array is going to be created in the heap memory? Yes? How do you know that? New keyword. New keyword basically tells that this particular array will be created in the heap memory. Congrats. Now, array is a linear data structure. It is going to store the data in a continuous memory location. Meaning, whenever you say that I'm going to create an array and this particular array is going to have 5 memory location, all the 5 memory location will be in a continuous order, one after the other. So you have 1, 2, 3, 4, 5. 5 memory locations are there. Now, all these 5 memory location can store only similar kind of a data. That's what this was. Yes or no? Similar kind of data. Are we on the same page now? Perfect. Now, for these 5 memory location, one more thing is going to be there. What? Indexes. Indexes start from 0, 1, 2, 3, 4. So over here, whenever we have index, index is going to be what? A dot length minus 1. A dot length is what? 5. 5 minus 1 is what? 4. Is this part clear to everyone? Perfect. Now this particular array gets created on the heap memory. Whatever gets created in the heap memory, any memory allocation that happens in the heap memory, any variable which is getting created in the heap memory is always going to be initialized with default value. So over here, 0, 0, 0, 0, 0. Now this entire array is going to have a hash code. Let's say this particular hash code is 777. Okay. Now, what was A? A was my reference variable, which basically stores the hash code of the array which is created in the heap memory. Is this part clear to everyone? Perfect. Great. Now, the next thing that comes into picture is, if I want to interact to this particular array, I need the reference. Okay. So I'm going to say A. A is going to give me hash code. But on this particular array, I have 5 memory location. So out of these 5 memory location, if I want to interact with the first memory location, I need to use the index. So I'm going to say A of 0. So this A is going to give me 777. On this 777 memory location, I want to access the 0th index. That's the reason we give the index. And equal to, I'm going to say 10. So that's how your value 10 comes into picture over here. All right, this is how you access an array. Is this part clear to everyone? Perfect. Now, the thing over here, guys, is this is the working of your array, right? Array is a linear data structure. Your data is going to be stored in the continuous memory locations. So all these memories are going to be next to each other. Okay, it's a very well organized data structure because it's arranging in a much more better way, right? Everything is next to each other. right? Now, we were talking about linked list. We said linked list is also a linear data structure. It is also going to store some data. But the way the data is going to be stored in a linked list is going to be different. So linked list is a linear data structure. Over here, guys, the data in linked list, let me just write it down over here. Linked list is basically a linear data structure. Over here, guys, in linked list, the data or your values are always going to be scattered across multiple memory locations. Your linked list is also going to be created in the heap memory. Remember that. Linked list is also going to be created in the heap memory. So over here, guys, what happens is your data is not stored next to each other. They are scattered across multiple memory locations. So let's say, guys, this is your heap memory. Over here, this is my first memory location, which can store integer kind of value. Just giving you a reference. Okay, here, let's say the value is 10. Now, the second value can be stored in some other memory location, not next to this memory 10. All right, it's going to be stored somewhere else. And over here, guys, what happens is a link is created. That's why it's called as linked list. Two memory locations are connected via a link. All right. Now, over here, let's say 30 is going to be stored somewhere over here. 40 is stored over here. So, let's say this is 30, this is 40. So, link will be created from here, 20 to 30, and from 30 to 40, there will be the next link which will be there. And this is how a linked list operates. All right. Now, over here, guys, all of these memory locations in linked list is called as a node. What it is called? It is called as a node. We will discuss about node, but remember, this is not going to be called as a memory location. It's going to be called as a node. So this is a node in the linked list. This is also a node. This is also a node. This is also a node. Whereas in your array, each of these memory locations are basically called as elements. Is this part clear to everyone? Now, over here, what did we observe? In array, the data is always going to be stored in a continuous fashion next to each other. Whereas in linked list, the data or the memory locations are always scattered. All right. So there is going to be a link which will be created among these memory locations. These memories are called as node. Clear? Now, what is the drawback of an array? The drawback of the array is size is fixed. Yes or no? Size is going to be fixed. Right? This is the drawback of the array. Once I say that I am going to create an array of size 5, I cannot change this particular array. All right. And if I want to change it or something, I have to use a collection. Array list comes into picture. Now, over here, guys, in linked list, the advantage is the size is not fixed because you are just creating links between different memories. So over here, all I need to do is I have to create a node. Once a node is created, I can have some data inside it, let's say 50, and I have to just connect the last node with this particular node. Is this part clear? So in this way, all I need to do is keep on creating new nodes and always keep on adding at the end. Is this part clear to everyone? Now, this was the starting of my linked list. Whenever a start happens, the start of the linked list, the starting node of the linked list is basically called as what? Head. It's called as head. And the last, which one? This is the last. And the last node is going to be called as tail. Is this part clear to everyone? The starting node is called as head node and the last node is called as the tail node. All right. What is the advantage of linked list? The advantage of linked list is that you can keep on adding new and new nodes. All right. But in array, I cannot do that. The size of the array is fixed. Is this part clear to everyone? All right. Quickly make a note of this particular point. Then we will talk about the concept of nodes. All right, guys, let's just talk about the concept of nodes. Okay. Now, if I just draw a linked list for you guys, this is my first node. Then I'm creating a link to the next node. Then I'm going to create a link to the next node. This is something, a linked list which I've created. So over here, this becomes my head and this becomes my tail. Now understand something. What is a node? All right. Node is going to have two things inside it. See, the first thing what node is having over here is the data itself. So a node basically consists of data. And the second thing a node basically consists of is the link. It basically knows from this particular node, okay, how do I go to the next node? It has the address of the next node. All right. So let's say it is going to have address, or I can just say the reference of the next node. All right. Now, over here, you see 10 is connected to 20. 10 is not connected to 30. 10 does not even know that 30 exists. All right. It only knows the address or the reference of the next node. Once we reach the node 2, only then I will come to know that there is a node 30 also that exists, because not only there is a data for 20, but it also has the address to the next node. Now, once we reach node 30, or let's say the third node over here, what is going to happen? We see that there is no other reference. Okay. There is no other reference to the fourth node, right? So since there is no other reference to the fourth node, this is the tail. This is the last element. Is this part clear? Now, over here, guys, if something does not exist in memory, what is the value for that? Let's say it's a reference variable, no? So let's say the reference of the next node. If something does not exist in the memory, right? What will be the value for the reference variable for 30 this node 3? Null, right? So over here there's no link, so the value will be null. Now let's say, guys, with these two things I want to create a node. How do I create it? We said that node is going to consist of two things. The two things which are going to be there inside a node is going to be data and address or the reference of the next node. So what I'm going to do is I'm going to create a class node. Observe carefully. Public class node. Node is going to have two things, data and address to the next node. Address basically means what? A reference variable. So over here, first you say that you're going to have data. So let's say data is there. 10, 20, 30. What type of data types? They are integer. So int, private. Perfect. Now, address to the next node. This is a node type of a data. This is a node type of data. This is a node type of data. So let's say I create a variable called next reference. This is a node. This is a node. This is a node. What will be the data type for next reference? If this is a node, this is also a node. Technically, this is a reference variable for this node, right? You are going to create next reference. The data type over here is going to be node, all right? And it's going to be private. Now observe. One more thing that we can do is, let's not make this private for now. Let's keep it like this. I'm going to create a constructor, node, int, data. This dot data equal to data. I will only focus on the data that you're going to give me the value. I'm not going to focus on this next reference. Is this part clear to everyone? Done, created. Like, this is the node. Yeah, this is the node. So over here, guys, let's try to create a node. I'm going to create your public static void main method. All right. Now, I'm going to create the first node. I'm going to create the first node. So I'm going to say node N1, or let's call this head, because this is the head, equal to new node. Okay. Now over here, your constructor only takes one value, right? That is, it is only going to take the data. I'm going to pass the data. None. What is this? Object. Class is going to be loaded into the memory. Instance variable is going to be created. Constructor is going to be called. This is my object. Okay. It's going to have one instance variable called data. Another instance variable is next reference. Okay. Next reference. Now, you are giving the value 10. This is going to be initialized with 10. Next reference. Is it a primitive data type or a non-primitive data type? Is it a primitive data type or a non-primitive data type? Node over here is non-primitive data type. What is the default value of a non-primitive data type? Null. So over here, null will be stored. Let me just write over here, null. All right. So this is my first node which I have created. This is my first node which I have created. Now, over here, let's say the hash code over here is going to be 777. Now, I want to create the next node. So only with 10, okay, as a reference, I can create the next node. So I can say head. You see, I did not make it private. I removed the private now. Head dot. I can access this reference now. Next reference. Next reference. Next reference. What is the data type of next reference? Node. Head was what? Node. When you were having head, which was having a node kind of a reference, you created an object equal to new node of 10. Next reference is also a node kind of a data. What are you going to do? You're going to create an object. What is going to happen? Class is going to be loaded into the memory. Instance variable will be created. Constructor will be called, right? So over here, another object gets created. Observe carefully. This is the data. Data is going to have the value 20. Put over here 20. Now, next reference, we are not setting over here the next reference for this particular object. So next reference is going to be what? Null. Now this particular object, guys, this particular object got created in, let's say, memory location 999. 999. So over here, I'll be getting a hash code. We are storing in the head dot next reference. This is my head dot next reference. Where null was written, it will be updated with 999 memory location. And this is how my link got created. Makes sense to everyone? Makes sense to everyone, right? This was my first object. This was my first node, right? This node has two things, data and the next reference, your reference to the next node. So over here, when I created the first object, data was set, but next reference was null, right? Because here we are not initializing your next reference. When I created the next object, new node of 20, all right, I was using next reference from the head node as my reference variable. So whatever this particular object or wherever this particular object was created, its hash code is stored over here. So 999 came over here. Make sense? Perfect. Now the same thing. Let's say I want to store another node. I'll use head only as a reference. Head dot next reference dot dot again the next reference equal to new node 30. What is this object? Class is going to be loaded into the memory. Instance variable will be created. We have two instance variable. And the next thing, constructor will be called. The moment constructor is going to be called, this becomes 30. Here you're going to have the value null. Let's say this particular object is going to be created on 444 memory location. So over here, this next reference right now, the previous next reference is storing the value, what? Null inside it, right? So I'll be just removing this particular null. This was 444. 444 will be stored. And this is how the linked list got created. So we have 3 nodes. Each node basically has a data and address to the next reference. Is this part clear to everyone? Perfect. Take a moment and just look at this particular code. Now, even if you did not get it in the first go, it's completely fine. It's completely fine. We will now go to Eclipse and we will start writing the code. Again, over there, I'll explain the stuff. All right. Slowly and steadily. Don't rush into completing this thing. All right. We'll do it very slowly. Clear to everyone? All right. Now quickly launch your Eclipse. All right, guys. I hope you have launched your Eclipse. I'm pretty sure most of you guys are a little bit scared about this linked list concept, but don't worry. We will learn it properly. We'll learn it slowly. Okay. Don't worry on those things. See, the thing is, whenever something new comes into picture, right, people are always scared of it. All right. I'm pretty sure most of you guys are studying linked list for the very first time. All right. Just don't be scared. Just be open to the changes that are coming in your life. You'll just do great. All right. Now, let's talk about linked list. The first thing over here, guys, is I'm in the logic building package and I will be quickly creating a class. Let's call this particular class as node class. Can you write it along with me? All right. So I've created this class node. Node signifies your linked list node. All right. I hope that makes sense. So over here, guys, let's say that if I'm going to talk about a linked list, all right, in a linked list, the elements are stored in the form of a node, or the data is stored in the form of a node. Node is going to have two things. What are the two things that node is going to have? The first thing it is going to have is data. And the second thing that it is going to have is the address or reference to the next node. Is this part clear to everyone? So inside this particular class, my dear friends, we will be creating two instance variable. The first instance variable, in simple terms, will create the data. All right. So I'm going to say private int data. Now I have to store the reference of the next node. All right. The reference of the next node. What is a reference variable? Okay. Is this a reference variable? E becomes my reference variable. Yes or no? Yes. E is going to be the reference variable. E is going to store the hash code of the object which will be created in the heap memory. Yes or no? So over here, instead of calling it E, I will say next. Is this part clear? Now, I'll not be making it private. I can of course do it off, but for this particular example, to reduce the complexity, let's not make it your private variable. I want to access it outside the class. Next thing, it's an instance variable. Now, what you do of the instance variable, where they will be initialized inside the constructor. So what you do, right click, go to source, generate your constructor using the fields and just select data. I don't need to initialize your next. All right, done. That's all we are supposed to do. Now, let me just delete this particular drawing. Now, before we go ahead and, start creating the objects, all right, I want to ask you something. What is data storing inside it? Data is an instance variable. Instance variable is going to be created in the heap memory. What is the default value for integer now? 0. So data is going to be initialized with 0. Next, the next variable. Next variable is also an instance variable. It is going to be created in the heap memory. It is a reference variable. Look at the data type. Just look at the data type. It's a non-primitive data type. What is the default value for a non-primitive data type? Null. Remember this part. Clear? So next is storing null inside it. Data is going to store 0 inside it whenever the object is going to be created. But because we have this parameterized constructor, we will be passing the value for data. So data will be updated with some other value. So that's the node class that we have created now. What I'll be doing is I'll be creating another class, and let's call this particular class as linked list runner. All right. Inside this particular class, I'm going to have the main method. All right, quickly create it. Is it done? Perfect. Let's put this guy on 50-50% view. I don't need this chap now. All right. Let's bring this guy a little bit to the left. Now, we'll do it together slowly. Here I decide to write node head. Why I'm calling it head? Because this is the first node which I'll be creating. In linked list, the first node is generally what? The head. And the last node is what? The tail. Right? So I'm going to say node head equal to new node. And here you see we have a parameterized constructor. So I have to give some value. All right. Have you done this part? Great. Now over here, understand how it works. Let me just save this particular class. Never forget to save the classes. You see there is a star over here, no? Sometimes people say that, Arey, I have written the code, but I'm not able to access the constructor. You forgot to save the class, buddy. That's the reason. Anyways, when this particular program is going to be executed, Java is going to be on the line number 5. Node head equal to new node. This is my LHS. This is my RHS. Which part will be executed first? Yes, which part will be executed first? Java is going to execute the RHS. This is an object. What happens when you create an object? Class is loaded into the memory. Which memory? Meta area. Next, instance variable will be created. Instance variable will be created inside which memory space? In your heap memory. So, in your node class, you have 2 instance variable. So, over here, let's say this is my object. Node object. So, over here, this is my data. Data right now is 0. And this is my next variable. The next reference is going to be initialized with null. Class is going to be loaded into the memory. Instance variable is created. We have 2 instance variable. And the next thing is constructor is called. We are passing 10. 10 is going to reach over here. This dot data equal to data. Data is 10. This dot data. We are changing this particular value to 10. Are we on the same page? Yes or no? Let's say this particular object is present on 777 memory location. Clear to everyone? Perfect. Great. Nothing fancy I have done so far. All right. Now, let's say I decide to add the next node. The next node can only be added after the head. The next node can only be added after the head because we have to create a reference. A link over here needs to be created, right? So over here, head, or let's say this node class basically has this next variable, right? I have to access this as my reference variable. You see, this is node next. This is node head. What you did, you created an object. Here, what I'm going to do, I'm going to create an object. But how do I access this next variable? That's more interesting. The simplest way over here, because it is not private, I write like this, head dot next. I will be able to access this instance variable outside of the class now. Now over here, my dear friends, this is the next node reference coming into picture because this data type over here is node. So let's say this is node equal to. When you were having a variable of node, you created an object. So the same thing over here, I'll have to do it. I'll say equal to new node of 20. The moment I do this, what is going to happen? A new object got created of node class. It is going to have two instance variable, data and next. It is also going to have next. Next will be initialized with null. Data is going to be initialized with 0, but then your constructor will be called this particular guy. Data is going to get the value 20. Let's say this particular object is going to be created in 999 memory location. Now this hash code 999, I am trying to store it where? Inside the next variable of this node object. So where null was written, it will be updated. It will be updated with 999. And that's how the link got created, because this node now has a data and it also knows where the next node is. Makes sense to everyone? So over here, this is my head. From the head, I can go to the next node, all right, which is this, all right. And if you look carefully, there's no next right now. Next is null right now, meaning this is the last element as of now. This is the last element. Clear? Now, one more time. Let's say I want to add one more element. Now, again, I can only add the element with head as a reference. Okay. So I can say something like this, head dot next. When I say head dot next, it is going to take me to 999 memory location. But what I want, I don't want to store something on the 999 memory location. I want to create a new node. So I'm going to say dot next. So this is also going to become a new node for me. Here also I'm going to create a new node. This is node 2. From node 2, I will be creating a new object. All right. So where this next is there, it is going to store the address or the reference of the third node. Let's say I will be creating an object quickly. I'm going to say equal to new node of 30. All right. The value is going to be 30. Class is going to be loaded into the memory. Instance variable will be created. Constructor will be called. This is data. Initially, it will be having the value 0. It will be updated with 30. Here, the next variable will be there. It is going to be storing null inside it. Let's say this particular stuff is on 444 memory location. So this object hash code 444 will be stored in the node 2 next variable. So over here where null was written, it will be updated with 444. And boom, the link got created. All right. So this is how you can create a linked list in the simplest form. Is this part clear to everyone? Great. Now, this is what I have written. I want you guys to quickly write this code by yourself. Can you write it off? Create a node class. All right. Then create a linked list runner. All right. And I have created 3 nodes. This is the first. This is the second node. This is the third node. Or you can just look at the object created over here. Quickly write it down at your end. All right, guys. I hope you have written the code now. Now, the thing over here, guys, is what we want is I want to traverse this particular linked list. If you run this particular program, nothing. You won't be able to see anything right now because we are not printing the data and all, right? Our main goal over here is now to traverse this particular linked list. Now, observe how we are going to do that. Just give me a moment. Yeah. So over here, guys, what I'll be doing is I will be creating a new method. Let's call this particular method as traverse method. All right. So let's call this traverse linked list. All right. So something is going to happen over here. So I'm just going to say this is going to be public static void traverse linked list. Now, if I want to traverse a linked list, I need the head, because without the head, I don't know from where to start. So I will be passing head over here. All right. So if I'm going to pass head, what is the data type of head? Node. So you're going to put it over here. Clear? So let's call this particular method over here traverse linked list, and you pass the head variable. Now, whatever I need to do it over here. Let's close this chap and just observe what I'm going to do now. Let's remove this, everything. Now, the first thing over here, guys, is let me just reconstruct the drawing for you guys so that you can see it in a much more better way. Let's delete this chap. Over here, guys, we have 3 nodes. We know that. Now, every node is going to have a data and a reference variable or the address to the next node. Till now, I was drawing the object in the form of a circle. Now, instead of that, I want to draw it like this. Observe. This is data, and this is your next variable. Now, the first data is 10. All right. Then, we are going to have the second object. This is 20. This is data. This is next. We'll come to the next variable. Just hold on for a moment. This is 30. This is data. And this is next. Now, assume, let's say this particular hash code was 777. This is 999. This is 444. Now tell me, for this particular object, the next should store what value? You will say 999. Perfect. For this particular object, the next should store what value? You will say 444. All right. This is how the link is created. For here, the next is going to store what value? Null, because there is no other node coming into picture. Great. Now, I have passed the head reference. Head is what? Head is going to give me the hash code. So over here, guys, we are passing 777. Now, what I will do is I'm going to create another pointer. All right. So I'm going to say node current equal to head. So what we did is we created a pointer. That a pointer which is going to point to 777 memory location. It's pointing to 777 memory location. This is a reference variable. Reference variable store what? Hash code of the object created in the heap memory. Head is storing what? Okay, over here, head is going to store what? Head is going to store 777 only. So that 777 value I have given over here. So technically, this is my current. Now I have to travel how long? I have to travel till the way next, okay, is going to have null, or till the time current is going to store null inside it. Because the moment this particular traversing is going to be completed, I will reach a point where current is going to become null, meaning there is no other node coming into picture. So I will say something like this. While current is not equal to null, till the time current is not equal to null, when will current become null? When I am reaching the last node. All right, last node. Okay. So what I'm going to do, system.out.println current dot, you see, I can access the next method or next variable, but I cannot access the data. Don't worry. What we will do is we're going to go to the node class, and I'm going to right click over here, go to source, generate your get data, because I want to retrieve the values. All right. So I'm going to save it, come back over here, current dot, you'll find this get data. All right. Now, if I click on the play button right now, all right, if I click on the play button right now, you might end up going into an infinite loop where only the first value will be printed, which is this 10, 10, 10, 10, 10, because current is just pointing to this 777 memory location and we are trying to do the get data. So I'm only getting the value 10, 10, 10, 10, but that's not what I want. Once I get the value 10, I want to go to 999 memory location, right? So what I'm going to do is, let's stop this particular program. How do I do that? Current right now is storing head. Once I got this particular value, can I say current equal to, I have to update current with 999 memory location. How can I do that? How can I do that? I can write over here current dot next. Current dot next. So it started with 777 memory location. It will print the data. Then current dot next is going to give me 999. So once the value is printed, now it is going to go to this 999 memory location. It's going to print 20. Then it is going to go to 444 because we will update it with 444. It's going to come over here. It's going to print 30. And then I will initialize current with null. So that time your program is going to stop. Current not equal to null. Null is going to be equal to null and your program stops. So now if I just remove this particular drawing for you guys, save it, click on the play button. And if I come up, click on the play button, 10, 20, 30. Like it does not look like a linked list. I'll just make it for you guys. All right. Click on the play. 10, 20, 30. You want a little bit of spacing. Okay. You can do that. Just attach a little bit of space. All right. Click over here. 10, 20, 30. Done. Finish. Is this part clear to everyone? All right. Now the benefit over here is you can keep on adding new and new elements. Again, if you say that I'm going to do next dot next and I give a different value over here, 40. If I click on the play button, 10, 20, 30, 40. Are they arranged in the same memory location? Meaning, are they in the consecutive memory location? The answer is no. They are stored randomly. Links are created between them. Is this part clear to everyone? So here you see that the first we have 777, then we were having 999, 444, then you created one more node, right? So this node can be in, let's say, 100 memory location. All right, so over here it is going to be 40. This is going to be null, but this 100 value will be updated and kept over here. Is this part clear to everyone? Clear? Perfect. Quickly write this particular code at your end. All right, quickly try to write this particular code by yourself. All right, I hope you have written the code by yourself now. Now, let's try to do a dry run for this particular program. Let's try to understand one more time how exactly the execution happens in the memory. All right, guys, I hope you have written the code. Now, what I want over here, guys, is see. Of course, I can just end this particular class over here, but the thing is, this particular foundation is going to be very important because only if you understand how a linked list looks and how the data and the links will be created in the memory, you will be able to do the reversal. Else, it's going to be very difficult. You will end up mugging up the code, all right, which I don't want for you guys. So over here, what we are going to do is, before we end this particular class, we will just look at this entire piece of code and we will try to visualize how this traversing is happening. All right. So I don't want you guys to do anything. Just observe this particular screen. Can you do that for me? Perfect. Let's get started. Now over here, guys, see, this is the linked list runner class. We will be executing this particular program, okay, because it has a main method inside it. Java is going to go inside this particular main method and it goes to line number 5, which is node head equal to new node of 10. Now tell me something. Which is the first thing Java is going to execute? Is it going to execute the LHS or RHS? RHS. This is the first thing Java is going to execute, a new node of 10. Now we already have a class called node.java. What happens when you create an object? This is an object. What happens when you create an object? Class is loaded into the memory, instance variable is created, and the third thing, constructor is called. Class is going to be loaded inside which memory? This node.java is going to be loaded inside which memory? Meta area, also called as method area. Okay, so they're the structure of the class. All right, all your static variables, all those things, they are created over there. All right, next, instance variable is going to be created. All right, now the thing is, instance variable are going to be created inside your heap memory. Now, for your linked list only, what I will be doing is, I will try to create an object in the form of a square shape, because that's a structure I will be using for reversal also. Now over here, if the object is going to be created, it's going to look something like this for us. or this is how I used to draw all the time. This was data. Data is going to have the value 10 inside it. And the next variable was next. All right. Next was initialized with a default value, which was null. And this was my hash code of the object. All right. And head, the head variable was storing the value 777 inside it. Yes or no? Right. So over here, this becomes my reference variable. This was my object. But what I'm going to do is I'm going to draw it like this. This is my node. Node is going to have two things. First, data. Second, the next variable. Data I'm giving over here is 10. The next reference as of now is null. This particular node is present on 777 memory location. Is this part clear to everyone? So head points to 777 memory location. Clear to everyone? Perfect. This particular line is done. Java goes to line number 6. Head dot next equal to new node of 20. We'll look at this particular line later because this is the LHS. Java is going to observe it later. On the RHS, we are trying to create a new object. Let's say another object gets created. All right. This is my second object of node class only. This is data and this is next. Data is what? 20. All right. And next, obviously, we are not passing anything. So it's going to be null. Let's say this particular object is created in the memory location 100. Now, this next variable which we have, this is a default variable. Okay, we are not giving any visibility over there. Let's assume it was public. Since it's public, it can be accessed outside the class. But it is an instance variable. It can only be accessed with the help of a reference. So that's the reason I have written head.next. What is the data type of next? Next is a node kind of a variable. It's node next, no? So it's actually a reference variable. So what I'm writing, head.next. Head.next. Okay, it's going to store whatever is the hash code for this particular object. What is the hash code? 100. So where null was written, it got updated with 100. And that's how, my dear friends, the link got created. Now, head has the data. Along with that, it has the address for the next node. Okay, where the next node is going to be there. It's going to be on the 100th memory location. Over there, the data is 20. And next is null, meaning this is the last node. Okay, the last node is called as tail as of now. Now, what I want to do, I want to store another node. So, new node of 30. So, what is going to happen? Another node will be created. Data is going to be 30. And next is going to be null. Let's say this is stored on 444 memory location. Data is scattered across multiple memory location, right? 777, 100, 444. Now I'm saying head. Let me use a different color. Head dot next is going to take me over here. Dot next. So whatever is the value, I will be storing it over here. So this is going to be what? 444. So this is going to be updated with 444. Is this part clear to everyone? Perfect. Now the next one that comes into picture, the moment this thing gets updated, next becomes 444, the link gets created. Next, head dot next dot next dot next. Head next next. So over here we are talking about this particular variable. This will be updated with the hash code of the new node. This is 40. This will be null. And let's say this is on 555 memory location. So if you have got the point, your 555 will come into picture. And this is how my link is created. So this, my dear friend, is my tail. This over here is my head. This is my tail. Clear? Perfect. Great. Now what we want to traverse the linked list. So I've created this particular method called traverse linked list. Now the thing is, if I have to traverse the linked list, I just have to give the starting node. See, over here, what is happening is only head is aware of the immediate next node. That is, head knows that the next node is going to be on the 100th memory location. Alright, then on the 100th memory location, when we reach, only then I'll come to know where the next node is. On the 444 memory location. Only when I come on the 444 memory location, I'll come to know where the next node is, 555. The moment I come to know on that I'm on the 555 memory location, I can access the data. Along with that, I'll come to know that this is the last node. Apart from that, there is no other way. Clear? Makes sense. So over here, we are only passing the reference, meaning we are saying that the node is on the 777 memory location. All right. So what we are going to do first is we are going to create another pointer. This current over here is going to act as a pointer for me. Okay. Current equal to head. Head is what? 777. No? So this is what current is going to do. It's going to point to the node which is there on the 777 memory location. Now, the thing is, if you observe carefully, we have to keep on traversing. We have to keep on traversing till the time we reach this particular stuff, meaning we get to a point where node is going to become null or the current is going to become null. So that's the reason my loop is while current not equal to null till the time I reach the last node. All right, I have to keep on doing it again and again, again and again. What I need to keep on doing it? First, I will print the data. Current dot get data. I've created a method now, get data, so that I can access this instance variable. Right? So over here 10 will be printed and then there will be a little bit of space. Then I'm going to update current equal to current dot next. Current right now is storing 777. Current dot next. What is there in the next? 100. So current will be updated with 100. Meaning, what is going to happen? Now current, where is eraser? Yeah. Current will start pointing to, current is going to start pointing to this particular chap. Alright. On the 100th node. Here also, 100 and not equal to null, condition is true. It's going to go inside. Current dot get data. Get me the data. What is the data? 20 will be printed for you. Then a little bit of space. Then it's going to go down. Current equal to current dot next. What is there in the current dot next? For 444. Current was storing 100 inside it. It's going to be updated with 444. Alright. Meaning current is going to reach over here now. It's going to act as a pointer for this particular node. Alright. 444 not equal to null. Condition is true. It's going to go inside. Current dot get data. What is the data? 30. 30 will be printed with a little bit of byte space. Then current equal to current dot next. What is the value of next now? 555 memory location. So over here, current will be updated with 555. Current is going to start pointing over here. Is this part clear to everyone? So every time current keeps on getting updated and it goes to the next node. It reaches the last node for us. Alright. So over here, current dot get me the data. That's going to give me 40. 40 will be printed on your console. Then current is going to be updated with current dot next. What is there inside next? Null. Current becomes null. Alright, current equal to null. Current not equal to null. Null not equal to null. Condition is false. Exits from the loop is going to come out. This is how you do the traversing of a linked list. Is this part clear to everyone now? Alright. Now what I want you guys to do is, before you jump to the next class, I want you guys to write the code again 2 times by yourself. Alright. And the way I have done the entire traversing, you will do it in your notebook. Can you do it? Alright. Quickly write this particular stuff. This is a very important class. Now, before I end this particular class, please remember, mark your attendance. People ask, how do you mark your attendance? Just go to the discussion section and just write over there, attended, completed, whatever you want to write it off, so that I come to know what exactly the people are studying over there. This is for me, okay? So that I understand what you guys are studying these days. All right, perfect. Now I'll be seeing you guys in the next class, guys. I hope you have understood this particular topic. Please don't go to the next class unless this particular topic is clear to you guys. All right. So that's it for this one, guys. I'll be seeing you guys in the next one now. Till then, take care. Bye bye. All right, guys, welcome back to the class, and I hope you guys are doing pretty good. So we are discussing how to reverse a linked list. And in order to just solve this particular problem, we first understood the concept of linked list, how exactly it operates. Now, before we jump into the whole logic of reversing a linked list, let's do a quick revision on your entire concept of linked list. All right. So what do you know about linked list, guys? See, when I'm talking about linked list is a data structure. What kind of a data structure is this? This is a linear data structure. And what are the other linear data structures you are aware of? You have your arrays, right? You have your stack coming into picture. They are also linear data structure. But the thing is, in linked list, right, even though the data is going to be stored in the linear order, the main thing is the memory locations are always going to be scattered. They are not in a continuous sequence. So in linked list, data is always going to be stored in something which is called as a node. So you will create nodes, and these nodes are going to be some way connected with each other. All right. So this is going to be the first node. It's going to have the value 10 inside it. It can have anything. Okay, I'm just putting the value 10. And this particular node knows where the next node is. So over here, I'm going to put 20. Then this becomes my second node, and this node knows where the third node is. So this is where I'm going to put 30. Now this entire stuff over here, guys, is a single linked list or singly linked list, what you call it. The reason it is called as a singly linked list, the only reason for that is we can only travel in one direction. Makes sense to everyone? I can go from 10 to 20. 20 does not know that there is a connection coming from 10. All right. 20 knows only the next node, that is 30. Is this part clear? Now, the first node which you see is called as what? The first node which you see is called as a head. And the last node which you see is called as a tail. Now, we also created a linked list in the last class, right? So over here, first we created a node. So if I will be having a node class, this particular class is going to have two instance variable. The first variable which I created over here was called data. And data type was integer. It can be any data type. I decided to go with integer. You can put string, you can put student class, you can put person class. It doesn't really matter. Data type, you have to decide it off. And the second thing you're going to do is you're going to create another variable of node type, which is going to act as a reference to the next node. Is this part clear? Then we introduced a constructor. So node, let's say this is integer data, curly bracket start, curly bracket end. We're going to say this dot data equal to data. The job of the constructor is to initialize the instance variable. Now, one more thing, if you remember, next, even though it is a instance variable, I did not mark it with private. Okay, you can make it public. So if I want to create a node now in your public static void main, all right, in your runner class, I had written something like this: node head equal to new node of 10. So this is how my node was getting created. This is my first node now. It is going to have data. Data is what? 10. The next thing it is going to have, the second reference variable was next. Next, as of now, is storing null inside it because next is a reference variable. Look at the data type. Okay. Sometimes you will say that, Ari Jatin, you're calling it a reference variable. Sometimes you're calling it as an instance variable. Reference variable, you have to check for the data type. Okay. If the data type over here is a non-primitive data type, all right, it becomes a reference variable. All right, a reference variable can be a local variable, it can be an instance variable, etc. So over here, guys, I have created it at an instance level. No? That's the reason it's an instance variable also, but it's also a reference variable. So we just have one node which is created. This is my node 1. All right. The next thing is I want to create another node. Create it then equal to new node of 20. So this is going to be my node 2. It's going to have the value 20. The data is 20. The reference is going to be null. The next reference is going to be null. But I want this link to happen, right? So I will say head dot next. All right. So where this next is there, right? It's going to be updated with the reference, the hash code of this particular object. Let's say this object was 777. So over here, 777 will be stored. Let's say this is going to be something like 555. So this is how the link will get created. Let's say you want to create another object. Create it equal to new node of 30. Here I can say head dot next. We are talking about this particular object and we want to access this next variable. All right. Then your new node will be created. This is going to be 30. Let's say this particular object is available on 888 memory location. All right. So over here, the next for this particular node is already null. So this next is null. But since we are using this next variable as a reference variable, the linking will be established. So over here, where you see null, it will be written what? It will be written what? Over here, it will be written 888. And this is how your linked list gets created. Perfect. Now, we also saw how to traverse a linked list. That particular code is very important. So let me just rub this particular stuff quickly. Whenever you want to traverse a linked list, what are you going to create? You are going to create a pointer. All right. And you have to pass what? You have to always pass the head reference. So what I'm going to create, I'm going to first create a pointer node current. All right. And current is going to be initialized with wherever the head is pointing. All right, head. Where head is pointing? Head is pointing to 555. All right. So this is my head pointer. Let me use a different color for you guys. This is my current now. Current is pointing to 555. Now we have to keep on reading the data, moving to the next memory location, reading the data, moving to the next location till current becomes null. Because the last node next reference is going to be null. All right. So over here we will say while current not equal to null. Keep on doing something. What? Print the data. Current dot get me the data, the getter I am using. All right. And then you have to update the current. I have printed the data, no? So now I have to take the next reference. I will say current, you get updated with the current dot next. What is current dot next? 777. Previously current was storing 555. Now current will be updated with 777. So your current, which was pointing to 555 memory location, will start pointing over here. This is my current coming into picture. Again, I will process the data. I will read the data, get data. It's going to give me 20. 20 will be printed on your console. And then I'm going to read current dot next. It's going to give me 888. All right. So current will again be updated and it's going to move to the next node, which is going to be on the 888 memory location. Again, we're going to process the data. 30 will be printed on your console. And then we will take the next value which is there, which is null. So current will be updated with null. Null not equal to null, condition is false. We exit from the loop and we are done. All right. So this is how we were doing the traversing of a linked list. Now, the thing is, we needed that foundation so that we can reverse the linked list. The reversing a linked list is very simple. It's not at all a difficult one. But the thing is, you need to first understand the traversal of a linked list. And in order to do that, you need to first understand how to create a linked list. That's the reason we had to take a longer route. Now, let's try to understand this problem statement of reversing a linked list. Over here, guys, what exactly this problem statement is all about? Let's say we want to reverse linked list. All right. So over here, guys, we will be given a linked list. All right. So let me just quickly create one for you guys. All right. This is 10, this is 20, this is 30. Over here, this particular node is going to be available on, let's say, 100 memory location. This particular node will be available on, let's say, 400 memory location. And this particular node will be available on 500 memory location. Now, tell me something. This particular node needs to point to this node. So what should be stored in the next reference? You will say 400, Jatin. I'm like, correct. That's how the link will get created. For this particular node to point to the third node, right? What should be stored in the next variable? You will say 500, Jatin. I'm like, correct. Very good. Next, over here, for this particular node, the next variable will store what? It is going to store null because there is no other node available. Now, when we say that we have to reverse a linked list, understand something. When we say we have to reverse a linked list, meaning what we need to do is we need to reverse these links which are there. Meaning, over here, these are the three nodes. This is 10, 20, 30. Addresses were 100, 400 and 500. You see, the links are basically pointing like this. We have to reverse the links, meaning 30 needs to point to this particular 20 node. All right, how can I do that? So over here where null was written, what should I store? So that the link gets created like in this order. You will say store 400, Jatin. I'm like, fine, great. For 20, this particular node, to point to this chap, what we need to do? What should be stored over here? 100. And over here, what should be stored over here? Null. Meaning, this was my head. Now this has become my tail. This was my tail. This has become my head. Is this part clear to everyone? We have to reverse the links. So all the references of the next needs to be updated. This is the program. All right. So let's try to understand the logic of this particular program. Now, guys, let's do it very slowly. Okay, we'll try to understand how to build this entire logic. I'm not in a rush to write the code, but the most important thing is once I understand the logic, writing code is going to be just a simple, easy cakewalk for us. All right. The first thing, if you look carefully, we have to definitely traverse this entire linked list. Yes or no? Because on every node, I need to keep on making the changes in this next reference variable. So definitely we need to keep on traversing the entire linked list. So what we can do is we can use the code from the traversing of the linked list, right? So definitely I will need a pointer. I'm going to call this particular pointer as current. Current is going to be initialized with head, meaning current is going to store the value 100 inside it. Is this part clear to everyone? All right. Now, over here, let's say I'll write the first line. That is, you create a node, let's say current, and current will be initialized with head. All right. And same, while current not equal to null, we need to do certain things. Is this part clear? Now, the first thing which I see over here for this particular node, okay, let me just use a different width. For this particular node, my dear friends, what do I see? That the next value needs to become null. You will say that is very simple, Jatin. I can just write something like this. Current dot next equal to null. Write it. So what is going to happen? This thing which was having 400 over here will be made null. Because current dot next, current is what? 100. This is the 100 memory location over there. Make this as null, right? So over here, if I do this, I got this particular stuff taken care. But this 400, guys, it was signifying something. It was the link between these two nodes. Only when I was able to read this 400, right, we were able to go to the next memory location. Now you made it null, meaning this link only is broken. Makes sense to everyone. This link does not exist anymore. Right? So the problem is I cannot put it null directly. Is this part making sense to everyone? Now, the next thing, if I cannot put this chap as null, but definitely I have to bring null over here somewhere down the lane, right? So over here, guys, my first challenge is I want to store this 400 numbers somewhere. I have to store this 400 numbers somewhere. Just like how we were using head, whatever the reference was there, 100 was there, 100 got stored in current. Na? I will create another reference variable. Let me use a different color only. Let's say orange color. I'm going to say node next. Node next equal to, okay, null. Equal to null. I'm going to initialize it with null as of now. So what has happened? I have created a reference variable called next. It is going to store node kind of a data. Basically, it's going to store the hash code of node object. What next is going to do? Next is going to store whatever the value is going to be there in the next variable. So somewhere down the lane, it is going to store 400, then 500, then null, maybe whatever. Okay. So the thing is, I want to access current next variable. So I'm going to say current dot next. That is going to give me what value? It is going to give me 400. This 400 value, I will store it inside the next variable. Can I do that? Yes. Now I have a backup. This is going to act as a backup for me because now what is happening? What is going to happen? This 400, right? I can update it. This next variable, I can update it. I can easily write over here with a different color for sure. Current dot next equal to null. Now I am able to update this chap with null. And I don't have to worry also. Why? Because the thing is, I know where the next node is. So this backup variable is going to tell me where the next node is. So I can just say, if I want to move current to the next location, meaning I want current to start pointing over here, I can say current, you take the next node address from the next variable. And over here, this 400 value will be given over here. And we reached over here. So we are partially there. I was able to update this particular node. Okay, whatever they asked for, 10, 10, null, null. And you were also able to move to the next node. But the thing over here, guys, is over here, it is written 500. And over here, it wants the address of the previous node. 100 I don't have now. I cannot go back also. So what I will do is, I will create another pointer. Okay, let's use a different color now. Which color looks good? Tell me. Let's go with red now. All right. I'm going to create another pointer called previous. And previous is going to store the hash code of the previous node. All right. So current dot next equal to null. All right. And here I will just say previous equal to current. Previous equal to current. But current dot next, this chap, we have to put previous. We have to put 100 over here, right? Previous is getting the value from current. This is going to get the value 100, right? But first, I will initialize previous with null also. So I'm going to create another variable. I'll put it over here. Node previous equal to null. And over here, we have written current dot next equal to null. Current dot next has to take the values of the previous nodes. So remove this null and put over here previous. The program is solved. Like, huh? Yeah, it is solved. Nothing. Observe carefully. So over here, before it goes to the next node, we are saying previous equal to current. So this null will be updated with 100. Then we are going to be on this particular node. Current not equal to null. Current is what? 400. 400 is not equal to null. Come inside. Next equal to current dot next. What is next? 500. What is next? Storing inside it right now? 400. Update it with 500. Alright. Current dot next equal to previous. What is there inside previous? 100. Remove this. Put 100 over here. So this link which was not there now got created. Look at this chap. 10 null, 10 null, 20 100, 20 100, 400 400, right? So this is also working for us. Current dot next was previous. Previous equal to current. Previous was previously 100. That I will update with the current. It has going to become 400. Current equal to next. What is there inside next? 500. So this is how your current, which was pointing to 400 memory location, will now start coming over here. Because this is 500 now. Now observe. This link is already removed. Alright. I can remove this chap. Next. Current not equal to null. Current is what? 500 not equal to null. Condition is true. Next equal to current dot next. Current is what? Current is what? 500. 500 dot next is what? Null. So over here, your next, which was storing 500, will be updated with null. Alright, this line is done. Current dot next equal to previous. What is there inside previous? 400. 400. 400. So this link got created now. Alright. Previous equal to current. What is there inside previous? Previous is having 400. What is current? Current is 500. Right? It's 500. So this 400 will get updated with 500. Right? Current equal to next. Current equal to next. What is there inside next? Null. So next, okay, the value null will be given to this. Again goes up. Current not equal to null. What is current? Null. Null not equal to null. Condition is false. This loop exits. This loop is not going to get executed anymore. So over here, my dear friends, what do you observe? The previous is having the value 500. So previous is going to act as a header for me. It's going to start the head for me. All right. And your entire linked list is reversed. Very important code. I hope you have understood the logic, guys. Now, what I want you guys to do is, first, I want you guys to do the entire tracing on your notebook. You have to do it by yourself. Once it is done, then we will write the code together. Quickly start to draw this entire stuff in your notebook and start tracing it off one by one. Can you do it for me? Great. Start doing it off. All right, guys. I hope you have done the entire tracing of this particular program. Now let's try to write the code for the same. All right. Open your Eclipse quickly. All right, guys. I hope you have practiced the entire tracing of the linked list code. Now, the thing is, let's write the code to reverse the entire linked list. Now, this is the same program that we have written in the last lecture. I will be using this particular program only as a reference. Now, if you look carefully, we have added a couple of nodes which have the value 10, 20, 30, 40. So if I'm going to right click, go to run as Java application, this is the output of this program. Now, what we want to reverse the linked list, meaning we want to reverse the links, not the data. So over here, what we will do, we will create a method first. Public static void reverse linked list. And what you do is you give me the head. Okay, you give me the head. What is the first thing that you will create? A current reference. So I'm going to create a current pointer and it is going to be pointing to the same head. Next, we need two more pointers. One for previous, I am going to initialize it with null, and one for your next. That is also going to be initialized with null. Now, this is where my story starts. I will start traversing the linked list. So, let's draw the things also parallelly. We have this particular linked list, right? So, let me use a different color. 10, 20, 30, 40. All right. So over here, let's say this is going to be 777, 900. All right. Then your 800, then 500. This is going to store null inside it. We know that part. So the links are like this. So this will store 500. This is going to store 800. And this is going to store 900. This is my head at this particular moment. And this is my current also. Okay. Your next and your previous are technically storing null inside them. Now start the traversing. How you're going to do? While what? Current not equal to null. All right. Current not equal to null. Now, before I make this guy as null, the next reference as null, what do I want? I want to create a backup of this next reference. So, we will store it inside our next variable. Next equal to current dot next. Right? So that we don't lose this 900. All right. The next thing that we will do is we are going to update the current.next now. Current.next equal to null. But the thing is, it should always store the previous value, right? So instead of putting null over there, we'll put previous, and later on we will update the previous. Then I will update the previous equal to current. So over here, 900 came over here. Then previous is going to take the value from current. This is going to store 777, right? And finally, we will move the current header to the next node. Current equal to next. So current is now going to be initialized with 900. All right. Current was pointing to 777. Now current is going to get the value from this next. So it's going to reach over here. Now is current not equal to null? 900 not equal to null. Condition is true. It's going to go inside. Current.next. What is there in current.next? 800. So over here, your next will be updated with 800. Current.next equal to previous. What is there in previous? 777. All right, 777. Then previous equal to current 900. Take this 900, put it over here. Current equal to next. What is there in next? 800. We're going to reach over here. This is how the links are going to be reversed. And you're done. Now, the thing is, reversal is going to happen. Even the head position is going to change. By the end, right, this 500 value is going to reach to the previous. All right. 500 will reach to the previous. So this previous is going to act as my head. So once everything is completed, what I will do? I will return previous. If I am returning previous, what will be the return type of this method? Node. And we are done. Finish. So copy this particular method, call it one more time. Internally only, what I'm going to do, I'm going to call reverse linked list and I'm going to pass my head. So it's going to reverse this linked list. It's going to give me the new head position and we will start printing the data from there. All right. So let's do one thing extra. I'm going to print this extra line, system.out.println, just an empty line, so that the data gets printed on the next slide. So if I'm going to click on the play button, bring this guy a little bit up, 10, 20, 30, 40, 40, 30, 20, 10, reversed. All right. Is this part clear? From 40, we are going to 30, from 30, we are going to 20, from 20, we are going to 10. 10 became my tail. Is this part clear to everyone? This is the program. Very important program, guys. Very simple also. You see, there's nothing fancy on this piece of code. All right. But still, I believe we have spent like 2 hours understanding this particular program. All right. So, you know that these things are not really possible to do it in your live classes. All right. Because the things, the props that I can use in my sessions like these, it's not possible to do it in live. All right. Please make sure you practice this particular code properly. All right. Do it 2 more times. If you get stuck somewhere, do let me know. We will discuss it off. All right. So that's it for this particular lecture, guys. We have discussed one of the most important interview question. It has been asked n number of times in product-based company. I haven't seen this particular question coming into any service-based company. So if you are applying for Infosys, Accenture and all, I don't think they're going to ask it. But if you are applying for, let's say, Adobe, or you're going to apply for PhonePe or BharatPe, chances are they will ask this particular question. All right. So that's it for this particular lecture, guys. Don't forget to mark your attendance. I'll be seeing you guys in the next one. Till then, take care. Bye-bye. All right, guys, welcome back to the class, and I hope you guys are doing pretty good. So in today's class, we will be discussing a very important interview question, which is check if an array is a mountain array or not. All right. So we have to check if an array is going to be a mountain array or not. Now, first, let's try to understand what exactly is a mountain array. It's very simple. Have you seen a mountain? All right. Let's say, guys, this is my mountain. All right. So when you look at a mountain, right? So the first thing which is going to happen over here is we will be climbing up the mountain. All right. So you always climb up the mountain. You are going to reach something which is called as a peak. And the moment you reach the peak, after the peak has been reached, you always climb down. Is this part clear? This is the concept of a mountain. All right. And that's the same concept for a mountain array also. So the first thing is, if I'm going to have a mountain array, I have to climb up. Climb up basically means that the element needs to be in the increasing order. 1, 2, 3, 4. And once I have reached the peak, let's say it is going to be 5, then what is going to happen? The elements must be in the decreasing order after the peak. So after 5, I cannot have 6 over here. It can be 3, it can be 2, it can be 0, right? So it doesn't mean that it has to be growing sequentially up. The elements or the numbers can be any number, okay? But these numbers needs to be in increasing order. And once you reach the peak, automatically the next elements onward, you should be climbing down, meaning the elements must be in decreasing order. Did you understand this part? Great. So we have to check whether the given array is going to be a mountain array or not. All right. Now this program is very simple. It's not difficult. Just because I tell that this is a very important program and all doesn't mean that it is going to be difficult. Once you understand the logic, writing code is the simplest thing. Are you getting the point? So we need to first understand the conditions, okay, how a array can be a mountain array. Now, the first condition for an array to be a mountain array is it should have minimum 3 elements. Okay. So, first, the length of array must be greater than 2. Right? Must be greater than 2, meaning 3, 4, 5, 6, so on and so forth. What happens if it is going to be 2 or less than 2? Let's say I want to have something like this. 1, 2. Now, of course, the element is increasing 1 and 2. On the 0th index, we have 1. On the first index, we have 2. Right? So, this is going to be the 0th index, and over here, I have 1. And the next one, the first index, I have the element 2. So, of course, we are climbing up. But the thing is, we reach the peak also. Now, we have to climb down also. There's nothing to climb down. All right. So, if I have to climb down, definitely there should be one more element coming into picture. So, the minimum number of elements should be 3. Is this part clear to everyone? So, over here, this is going to be my second index, and over here, 0 can be there. All right. So, how can you check this particular condition? Pretty simple. I will say if a dot length, okay, my array dot length is less than 3, is less than or less than 3 will work, less than 3, then I will return false. False over here signifies that this is not a mountain array. Is this part clear? Perfect. The next condition over here, guys, is the elements from 0th index to I index, because you don't know, right, when exactly the peak will come into picture. The I index, it should be in increasing order. All right, it should be in increasing order. So over here, let's say I can have something like this: 1, 2, 3, 4. All right. So on the 0th index, I have 1. On the first index, I have 2. On the second index, I have 3. On the third index, I have 4th. So over here, our elements are in increasing order. So over here, this is going to be 1, 2, 3, 4. So definitely we are climbing up. Makes sense to everyone? So it should be immediately increasing. Okay, it should be immediately increasing. So if I want to say something like this, 5, 1, 2, 3, 4, is this going to be immediately increasing? No, we have 5 now. After 5, we have 1. Then we are increasing 1, 2, 3, 4. So over here, this is not a mountain array. So the elements from 0th index to I index, it should be in increasing order. How can you check that particular condition? I can say if, look carefully, this is 0, this is 1. So I can say A of 0, A of 1. It should be greater. This is A of 1, this is A of 2. So this is A of 2. A of 2 is greater than A of 1. This is A of 3, right? Like this. Is this part clear to everyone? Perfect. They should be in increasing order, meaning I cannot have something like this also. 1, 2, 3, 3, 4. This is not a mountain array. Why? Because then you have reached a plateau, na? The threshold has been reached. So over here, your A of 3, this, let's say this is going to be third, this is going to be the 4th index. So 3 less than 3, this condition is going to become false, na? So over here, the elements must be unique and they should be in increasing order. Clear to everyone, right? So I have to write something like this. Your A of I plus 1, okay, where I is your index, should be greater than A of I. Makes sense to everyone? Perfect. This is my second condition. Now the third condition over here, guys. Once I reach the I, okay, the peak, all right, the thing is we should be decreasing from there. The elements must be decreasing. So 5, 3, 2, 0. Let's say this is A of I. This is going to be A of I plus 1. Okay. So over here, your A of I should be greater than your A of I plus 1. Make sense? Perfect. Similarly, your A of I plus 1, let's say this is going to be A of I now. So over here, this should be greater than the next element. So the third condition over here that comes into picture, once you reach the peak, the elements must be strictly decreasing. How can I do that? I can say if A of I greater than A of I plus 1. Make sense to everyone? Yes? Quickly make a note of this particular point and then we will try to discuss the logic of this particular program. All right? So now guys, once we have understood the conditions, all right, let's try to check whether an array is going to be a mountain array or not. So let's say we have been given an array, okay, and we have elements something like 1, 2, 4, 6, 3, 1, 0. Okay, this is my array. Let me just draw it off for you guys. Something like this. 1, 2, 4, 6, 3, 1, 0. This is my 0th index, 1 index, 2 index, 3, 4, 5, 6. Now, the first thing, before I check whether it is going to be a mountain array, I'll start comparing the elements and all. I'll do a simple check. What is the first check? That the length of the array should be greater than what? 2. There's something should be there. So what I'm going to do is, the moment I am been given an array, all right, what I'm going to do is I'm going to check if a dot length is less than 3. Okay, I'm going to return false. And this false over here means that this is not a mountain array. Clear? Great. Now, what I will start doing, I will start climbing this particular mountain. So let's assume we have the elements like this. 1, okay, then you have 2, then you have 4, then you have 6, then you have 3, then you have 1, then you have 0. What I will do is, now, this is where I am starting. Okay. This is the 0th index. This is the first index, second index, third index, fourth index, 5 index, and 6th index. All right. I'm going to create a variable called integer I. I is going to be initialized with 0. Once I know that the length is greater than or equal to 3, that is, it can be a mountain array. All right. So first I'll do a length check. Then I'm going to create a variable int I equal to 0. So we are over here. We are focusing on this particular element. What we are going to do over here is we will start climbing up this particular mountain. So I will say while, okay, because I don't want to go with a for loop. I want to go with a while loop. While I, okay, or you can write something like this. Your A of I is less than A of I plus 1. Okay. So while A of I is less than A of I plus 1. I is what? 0. Less than A of 0 plus 1. A of 0 is 1. 1 less than A of 1. What is A of 1? 2. The condition is true. So this is going to be 1 less than 2, right? So the condition is going to be true. What we will do? We will climb up. So from here, I will try to come over here. Meaning, I will increment I. Is this part clear? If this particular, the next element is going to be bigger than the current element where I am standing, then I'll climb up. Make sense? Is this part clear to everyone? So I'll keep on doing it again and again. Then again, I is going to be right now, let's say 1. So over here, we will compare this and the next element. A of 1, because I right now is 1. A of 1 less than A of I plus 1. That is 1 plus 1. So A of 1 less than A of 2. What is A of 1 right now? 2 less than. What is A of 2? 4. Condition is true. Again, I'm going to climb up. I'm going to come over here. Is this part clear to everyone? Then again, what we will do? We will climb up. Okay. So what I'm going to do? Your I plus plus is going to happen from I equal to 1. It is going to become I equal to 2 now. Okay. The new value of I is going to be 2. So I'm going to compare A of 2 with A of 3. I plus 1. The value of I right now is 2. So A of 2 plus 1. A of 3. A of 2 is 4. 4 less than 6. Condition is true. You're going to go down inside this particular loop and it will be incremented. I is going to become 3. Makes sense to everyone? This is where I have reached. This is where I have reached. Now, the next stuff. This and this. This and this. A of I less than A of I plus 1. A of I is what? I is 3. Less than A of 3 plus 1. A of 3 is 6. 6 less than A of 4. A of 4 is 3. Right? 6 less than 3. Condition is false. It's not going to go inside the loop. It's not going to go inside the loop. So this while condition is going to fail. And then it should come out over here somewhere. Now, since this particular value is less, what do you conclude? We are going down now. We are going down, right? So, what we will do is we will introduce another loop. While A of I greater than A of I plus 1. This is the stuff. I'll keep on incrementing I. I'll keep on incrementing I. Like why? Observe carefully. So over here also this particular loop will be executed and we will go down now. I will be incremented. 3 has become 4. Then these two elements will be compared. Again, we are going down right now, right? So again, I will be incremented. We're going to come over here. Again, your I will be incremented. So the thing is, if this was a mountain array, we would be able to climb up and then we will be able to climb down. The total number of steps, 1, 2, 3, 4, 5, 6, 7, right? The total number of steps would be equal to your length of the array. Is this part clear to everyone? We started from 0, 1, 2, 3, 4, 5, 6, right? So over here, this is 6, correct? The length over here is 1, 2, 3, 4, 5, 6, 7. So I can just say a dot length minus 1 if is equal to I. This can be a mountain array. Or this is a mountain array. Makes sense to everyone? Perfect, right? Can we start writing the code for it together? All right, quickly launch your Eclipse. Okay, just take a moment over here. I want you guys to again just go through this entire stuff one more time. Okay, and then we'll start writing the code together. All right, quickly just go through this particular flow. All right, guys, I hope you have launched your Eclipse. Now, what I'm going to do is we are going to go to the logic building exercise project. In the logic building exercise project, you go to the com.logicbuilding package. Over here, you quickly create a class. Let's call this particular class as mountain array check. All right. And we will be introducing the main method. And over here, guys, what we will do, we are going to have an array. I'm going to quickly create an array, which is going to have elements like 1, 3, 5, 10, your 4, 2, 0. My question to you guys is this a mountain array? So if you notice carefully, over here, the elements are increasing. Yes, they are reaching a particular peak. Okay, this is where your peak is, and then we are decreasing. Is this part clear to everyone? So this is a mountain array. So over here, what I'm going to do is I'm going to create a method. I'm going to call this particular method as mountain array check method. All right, and I'm going to pass my array reference to it. Bring your cursor over here, quickly create this particular method. This particular method is going to return me true or false. All right. Now, what is the first condition? The first condition is that the length of the array must be greater than 2. All right. So I'm going to write a reverse condition for that. If a dot length is less than 3, if a dot length is less than 3, meaning there are less than 3 elements in the array, I'm going to return false. Is this part clear to everyone? Next thing. Condition number 2 is the elements must be in increasing order. Or I would say strictly increasing order. Strictly increasing basically means that I cannot have another 5 coming into picture, because then what is happening? It's increasing, and then these two elements are equal. So this is not strictly increasing. All right, you cannot have equal values over there. Okay, so over here, guys, we are going to create a variable called I, and it's going to be initialized with 0. So technically, we are on the first index, that is on 1. And we will start climbing. All right. So over here, what I'm going to do, I'm going to have this while loop coming into picture. Let's write a little bit up. While a of I is going to be less than a of I plus 1. All right. Then what I'm going to do, I'm going to increment I. Null. Similarly, Once I reach a particular point, let's say I'm going to reach this particular elements 10 and 4. So over here guys, what is going to happen? Let's say we have reached this particular element. This is 0, 1, 2, 3, 4, 5, 6. So when you will be on A of 3 and you will try to compare whether A of 4 is greater than A of 3, what is going to happen? Over here, this is 10, 10 greater than 4, the condition is false. This false signifies that you are going down. Makes sense? So what we will do? We will create another while loop. Okay. So once A of I plus 1 is going to be less than A of I, that time this particular while loop is going to be stopped from execution. We will come out of this particular while loop, and here I will check if A of I is going to be greater than the next element, your I plus 1, A of I plus 1, then again I'm going to continue with the stuff. And let me just print this thing for you guys. System.out.println I. Alright, let's do a Control-Shift-F. Okay, and I'm going to return false. It doesn't really matter for now because I want you guys to see what is going to be there inside I. So if I'm going to click on the play button, we are going to get array index out of bound exception. Okay, index 7 out of bound for length 7. So here we also need to introduce one more condition because we are writing I plus 1, right? So what is happening? There can be an issue that you will go out of the range of your array. So I will introduce one more condition, and that one extra condition that you're supposed to put over here is to check whether I plus 1 is less than 8 dot length. Okay, and then your remaining condition. Similarly, copy this particular stuff, put it over here. So this is just to ensure that you are within the range. Okay, the I plus 1 should be less than A dot length. Okay, if I'm going to click on play button, you see I'm getting 6. How many elements are there in your array? 1, 2, 3, 4, 5, 6, 7. Index is going to be 0, 1, 2, 3, 4, 5, 6. So over here, this is what? A mountain array, because we are strictly increasing, we are reaching a peak and then we are decreasing. So if it is going to be a mountain array, you would have climbed the mountain and you would have also come down. So the steps will be equal. So over here, what I'm going to say, cut this. And I'm going to say something like this: return A dot length minus 1 equal to your I. So whatever is the result of this particular comparison, if A dot length minus 1 is equal to I, it is going to return me true, else it is going to return me false. If you don't want to write like this, what you can do, you can say if A dot length minus 1 equal to I, return true, else I'm going to return false. Alright, and we are done. Let's click on the play button, but we have to just make sure that we are printing the result over here. Alright, so I'm just going to call this particular method over here. Click on the play button and it's true. Let's change it. Okay, let's click on the play button. False. Alright, because these two elements have become equal, right? Now, let's say I just change it to something else. 6, 3, 5, 10, 4, 2, 0, 0. Of course, this is not a mountain array. False. Alright, so let's say 6, 13, 15, 20, then again 14, 12, 10, and 5. Alright, we are increasing and then we are decreasing. So if I'm going to click on the play button, this is a mountain array. Alright, I hope you have understood this particular program. Now, quickly write this particular code at your end. Then we'll try to do a dry run for this. I want you guys to remember this particular logic properly. So I'll explain you the code one more time. Quickly write this code at your end. All right, guys, now let's go ahead and understand the logic of this particular program one more time. See, guys, this is a very important interview question. And I'm pretty sure that if you're going to apply for any product based company or even some of the MNC companies, they can really ask this particular question during the coding rounds. So please do not mug up the code. Always understand how this particular program is solved or any program is solved, because once you understand the logic, it is going to give you a lot of confidence of writing the code by yourself. You will be able to understand different code, because once you understand how the program execution happens, okay, it is going to give you a lot of confidence on solving other problems. Is this part clear? Great. Now over here, guys, we have been told that we have to tell whether an array is a mountain array or not. So we have been given an array. Now this particular array has different numbers or elements: 6, 13, 15, 20, 14, 12, 10 and 5. So in total you have 1, 2, 3, 4, 5, 6, 7, 8. So the size of this particular array is 8. Is this part clear to everyone? Now, so how will I come to know whether an array is a mountain array or not? Obviously, the first thing is the the condition that comes into picture for checking whether an array is going to be a mountain array or not is that the length, okay, or the size of the array should be greater than 2, meaning the minimum number of elements, okay, the minimum number of elements should be 3. Clear to everyone? Because let's say if I'm going to have an array which is going to have elements 4 and 5. Can this be a mountain array? No, a mountain looks like this, na? So we have to have 3 elements. Here is 4, here is 5. What is next? There should be some elements coming into picture. Let's say 3 can be there. So the minimum number of elements for an array to be a mountain array will be 3. Hence, in this particular method called mountain array check, the first thing which I am doing over here is I'm checking whether the length is less than 3. Okay. If the length is going to be less than 3, okay, if the length is going to be less than 3, I'm going to return false. What is the significance of false over here? The false basically tells over here that this array, whatever the array that you have given, if the length is going to be less than 3, it cannot be a mountain array. Is this part clear to everyone? Perfect. This is the first condition. What is the second condition? The second condition is that the elements must be strictly increasing. What do you mean by strictly increasing? See, if I'm going to have 3, 3, 4, is this strictly increasing? No, because the first element is 3, that is on the 0th index we have 3. Then again we have 3 coming into picture. So this is not increasing, they are equal only. Na? And then you are going on the 4th number. So over here, this is not strictly increasing. Strictly increasing can be 3, 4 and 5. So we have 3, from 3 we are going to 4, from 4 we are going to go for 5. So 3, 4 and 5. This is strictly increasing. Okay. Once we have reached the peak, the elements must be strictly decreasing also. So 4, 5, and if you look carefully, after 5 we are coming to 3, right? We are coming down. So this is going to be a mountain array. So the elements must be strictly increasing. Once we have reached the peak, the elements must be strictly decreasing. Is this part clear to everyone? Now for strictly increasing, you have 3, 4, 5. This is 0 index, this is 1 index, this is 2 index, right? So your A of 0 must be less than A of 1. and a of 1 must be less than a of 2. This is what you call as strictly increasing. Can I write it like this? A of I, where I is the index, it should be less than a of I plus 1. Make sense? Now, the next thing that comes into picture for strictly decreasing, let's say this is 3, 4, 5, and then you're going to have, let's say, 2 coming into picture. Okay. So this is going to be my third index. So your a of I must be greater than a of I plus 1. Okay. This particular condition is for strictly decreasing. The previous or the current index, okay, let's take it as current index. The current index value should be greater than the next index. Make sense? So over here, this is what your strictly increasing and strictly decreasing conditions are. Now, one more thing over here is why I have written I plus 1 less than a dot length, right? This is an extra condition which I have kept over here. Now, look carefully. Over here, we are trying to access the next index value. The next index value. So let's say you have having the value 1, 2, 1. Okay. So over here, is this a mountain array? Yes. The elements are increasing and then it is decreasing. So over here, guys, we reach this particular index. This is what 0 index, 1 index and 2 index. Now over here, we have this particular condition, a of I should be less than a of I plus 1. Now over here, a of I is going to be what? A of 2. A of 2 is going to be less than a of 3. That is 2 plus 1, na? The next one. Do I have the third index? Yes. No, I don't have a third index. So it will give me array index out of bound exception. Clear? So to ensure that there is a next index that I can travel, I have this particular condition. Because of this particular condition, I will not get the array index out of bound exception. I'll check whether I plus 1 is less than a dot length. Okay. I plus 1 is what? 3. Because if I'm going to be on the second index, 2 plus 1, it is going to be 3. 3 less than a dot length. 1, 2, 3. 3 elements are there. Is 3 less than 3? The answer is no. 3 is equal to 3. So since this particular condition is going to be false, we will not go to the next one. Make sense? Since I will not go to the next one, I will never get an array index out of bound exception. Clear to everyone? Is the condition part clear to everyone? Great. Now, let's try to understand the flow of this particular program. So we have seen the different conditions that are there, okay, for your mountain array check. Now let's see how exactly this particular program will be working. All right. So over here, we have been given this particular array. What I'm going to do, guys, is I'll try to create this particular array not in a linear form, but in a form of a mountain. So we have 6, you have 13, you have 15, you have 20, you have 14, you have 12, you have 10, and you have 5. 1, 2, 3, 4, 5, 6, 7, 8. All right. This is how the mountain looks right now. Let's do one thing. I'll put steps also. First step, second step, third step, fourth step, fifth, sixth, seventh, eighth. Let's put the index also. This is 0th index, 1 index, 2 index, 3, 4, 5, 6, 7. So this is my array. All right. Now we have to tell whether this is going to be a mountain array or not. Now understand something. Let's see. I have created this particular variable called int I equal to 0. This is where I am standing right now. Okay. On the 0th index. All right. Now, what I will do is I will check I plus 1 less than a dot length. I plus 1, 0 plus 1, 1. Is there a next step that I'm supposed to take? Is there a step that I can climb right now? The answer is yes. And a of I less than a of I plus 1. A of I is what? 6. 6 is less than 13. The answer is yes. Meaning, over here, the value is increasing. The next value, the value which is there on the first index is greater than the value which is there on the 0th index. Since there is a next step, which I can take, and the value on the 0th index is less than the value on the first index, I will take that step. I will climb. And I is going to become what? I is going to become 1. I will increment I, no? So I will become 1. Again, I will take that particular check now because we are in the while loop. Now, again, the next step, I equal to 1. Okay. I will see whether there is a next step. So, is there another step, I plus 1 less than a dot length? Yes. Can I go to the next step? The answer is yes. And I will only climb if a of I is going to be less than a of I plus 1. What is a of I? A of I is a of 1 less than a of I plus 1. What is a of I plus 1? 1 plus 1, that is going to be 2. So, a of 2. A of I is 13. 13 less than a of 2, which is 15, right? So, yes, 13 is less than 15. The condition is true. So, I will climb. Since I have climbed it, I will increment I equal to 1. It is going to become I plus plus. So, I is going to take a new value, which is going to be 2. I equal to 2. Now, you're going to do this particular comparison. Is there a next step that I can take? I plus 1 less than a dot length. I plus 1 is going to be what? 2 plus 1, 3. 3 less than 8. Condition is true. So, I can definitely climb. But is a of I less than a of I plus 1? A of 2 is less than a of 2 plus 1, which is 3. Yes? The answer is yes. This is 15. 15 less than 20. Condition is true. So, I will climb up. Okay? And I is going to be incremented. I is going to take the value 3. Now, if you look carefully, we have climbed up and we have reached the peak. Correct? I has become 3. Now, over here, guys, if you look carefully, the values are decrementing. So, again, I plus 1 less than a dot length. I plus 1 is 4. 4 less than a dot length. A dot length is 8. 4 less than 8. Condition is true. Check for the second condition. Is a of I less than a of I plus 1? A of I is what? A of 3 less than a of 3 plus 1, which is 4. Okay, 20. A of 3 is 20. 20 less than your 14. Is 20 less than 14? Condition is false. True and false. The resultant is false. Okay, since this particular condition has become false, we will not enter into this particular loop anymore. We will come out. Make sense? Is this part clear to everyone? So, over here, guys, we have reached a place where the values are going to decrement now. Okay. So, what is the next thing that we are going to do? We will be having a second loop. And the second loop is going to check, are the values decrementing? All right. So, let me just rub this particular board quickly. And let's scroll down to the next loop, which is this. So, over here, again, this is for making sure that there is a next step that I can take. Okay, I plus 1 less than a dot length. Yes, this is true. So, I can definitely come down and I'll check whether the current value is greater than the next value. A of 3, because I is 3, is this greater than A of 4? 20 greater than 14. The answer is yes, it's true. Since both the condition is true, we'll come down and we will increment I. I is going to become 4. So, this is where I am. Make sense? Next, again, I'll check. I plus 1 less than a dot length. I plus 1 is what? 5. Because I is 4. 4 plus 1. 5 less than 8. A dot length, right? A dot length is 8. So over here, this particular condition is true, and over here, a of I is a of 4. Is it greater than a of I plus 1? That is 5. This is 14 and this is 12. 14 greater than 12. Condition is true. Since the condition is true, come inside the loop, increment the value of I. Value of I is going to be 5. Meaning will come down over here. All right. Again, we'll do the comparison for these two values. Okay. Over here, a of 5, is it greater than a of 6? Because there is a next step. I plus 1 less than a dot length. I plus 1 is what? 5 plus 1, that is 6. 6 less than 8. Condition is true only. And over here, we will check whether a of 5 is greater than a of 6. So over here, this is going to be true because this is 12 greater than 10. Condition is true. We will increment the value of I, meaning will come down. And then we will check for these two jumps. Okay. So over here, we'll first check whether I can take the next step. I plus 1, 6 plus 1, that is 7 less than 8. Condition is true. Then go for the second condition. A of I, a of 6, is it greater than a of 7? A of 6 is 10, 10 greater than 5. Condition is true, come down. We are incrementing the value of I. I has become 7 now. Alright, I has become 7. Now, I plus 1, 7 plus 1, is it less than a dot length? A dot length is 8. 8 less than 8. Condition is false. 8 is not less than 8. 8 is equal to 8. So over here, because there is no next step, I can't take this particular step now because we have reached the last index, last memory location. I cannot take the next step over here. Okay. We will not increment the value of I. Now, if this was a mountain array, we would have definitely climbed up and then we would have come down. Meaning, the steps which we took will be equal to the last index. A dot length minus 1. 8 minus 1, 7. What is the last value of I right now? I is over here. I is, the last value is 7. Okay, it's 7. Okay, and if a dot length minus 1 equal to I, if this particular condition is going to be equal, it is a mountain array and I'll be returning true. Else, I'll be returning false. And we are done. All right. I hope you have understood this particular program. Okay. Now, what I want you guys to do is, I want you guys to just delete the old file. You created the code, right, of mountain array check. Delete that particular file. Write the code again by yourself. Okay. Write the code again by yourself. Each program in the logic building module, you're supposed to solve minimum of 5 to 6 times. If you want to make sure that you are confident in your logic building or in the coding routes, okay, solve the programs 5 to 6 times and you will do just wonders. All right. So that's it for this particular lecture, guys. I'll stop over here now. Don't forget to mark your attendance. Now I'll be seeing you guys in the next one. In case of any doubts and queries, you know where to reach out to me. And take care, guys. I'll see you guys around. Bye-bye.